Tonight I wanted to talk about what I see as one of the really big questions we have to ask and that the world community has to answer. Whether it's yes or no, it's a question that we need to consider. Do we need a global agreement to solve the climate change problem? So I'm going to begin by spelling out to you what the current state of science is about the climate change problem. How big a problem do we have? And then I'm going to talk about the current state of affairs in terms of international negotiations, some of the impediments that we face and prospects going forward. Just so you know, I think the answer to that is yes, and I'm going to basically present the yes case tonight. But at least one of our panellists will beg to differ, I suspect. Well, this graph, you've seen graphs like this before, and you're going to see a lot more in the coming years. The bottom axis is time, 1900, year 2000, year 2100, and the vertical axis here is global mean surface air temperature above pre-industrial temperature. So this is how much the average planetary temperature has increased and will increase compared to what the typical temperature was before the industrial era, when we started major greenhouse gas emissions from burning fossil fuel. And this has been given to me as a personal communication from a colleague who's doing modelling for the next IPCC report. This is a little sneak preview. And rejections are business as usual, i.e. if we continue with fossil fuel use and emissions as we currently are, and we kind of take a worst case scenario. This is projecting where the temperature increase will hit by the end of this century, and we're up around +5 degrees. Okay. So business as usual takes us to really major climate change. And it's worth pointing out that this is just a statistic. If you think about it, the global average daily temperature is just, the problem with talking about average temperatures is no one lives in a place called average, right? It's just a statistic. And there are other statistics that, I should mention this too. People talk about the 2 degree guardrail. Current modelling suggests that we want to avoid any more than 2 degrees global warming, okay? The world community has agreed to try and limit global warming to no more than 2 degrees, and for reasons I'll talk about later. So there's a big gap. We're potentially heading to somewhere that's 3 degrees above what everyone has agreed is kind of an acceptable amount of climate change. And it gets even a little bit more worrying because when you change the mean value of something, you change the whole distribution. And this is from a recent paper by Jim Hansen, who's a NASA scientist. And what he looked at, this isn't model data, this is actually empirical analysis. The green is the distribution between 1951 and 1980 of extreme heat day events in the USA, in North America. And what he showed was, and the red is the last 10 years, and what he showed is in the last 10 years, there's been an increase in the frequency of extreme heat day events, such that he predicts that by 2050, what was +3 standard deviation extreme heat day events becomes the norm, and what's +5 standard deviation events become common. So basically the distribution is shifting to the right, and what's currently a rare and unusual heat wave event will become normal. So the more we change the mean temperature, the more we change the frequency of extreme events, and it's the extreme events which really are problematic in many extents. People often ask me, well, how bad can it get? I mean, if we keep burning fossil fuel, will the temperature keep going up? And will the frequency of extreme events keep going up, and will they keep getting hotter? I mean, is there a limit to the greenhouse effect? And I always like to show this graph. This is some planetary statistics, environmental statistics about Earth. If you take the temperature at the top of the atmosphere, it's about 5 degrees, okay? And that's the impact of radiation on warming the top of the atmosphere. If you look at the surface of the Earth, put a thermometer about a metre up from the surface of the Earth, the average temperature is about 17 degrees. It's warmer to the greenhouse effect. The greenhouse effect is natural, and those greenhouse gases trap some of that outgoing heat and warm the atmosphere up about 12 degrees above what it would be if there was no greenhouse effect. This is Venus. It's a bit closer to the Sun, quite a lot closer to the Sun. So it's got some more solar energy. At the top of the atmosphere, it's about 58 degrees. But look at the temperature, 477 degrees. And look at the greenhouse gas composition, 98%. It's got a lot of atmosphere. It's 90 times more dense atmosphere than ours. And we've got 0.04% CO2, it's got 98%. So this difference of about 420 degrees is due to greenhouse forcing. So the greenhouse is a very, very powerful lever. It's far more powerful than the distance to the Sun. So again, my colleague has kindly lent me this graph which is projecting business as usual into the future, and most of the graphs stop at the year 2100, and this is because the Intergovernmental Panel on Climate Change, which is the scientific body that presents to the governments the synthesis of the state of scientific knowledge about climate change. It's actually an intergovernmental body. The board of management is run by governments. They requested in the last report that the projections only be taken to 2100 because that's far enough into the future, and it hurts our brains to think anymore, if you like. Or not really. People thought that was a long enough time scale for decision makers. But the question I ask is, well, how bad can it get? Well, that's what the last graph was. It stopped at 2100. What if we take it around to 2300? We get a projection like this. Okay. So business as usual, worst case scenario, by the end of 2200, we're up to plus 12, not plus 5. And by 2300, it becomes unthinkable. So, whilst 100 years is almost inconceivably long in terms of government planning and government processes, and 200 years is almost science fiction for most governments, the reality is what we do today and in the coming decades is setting us on a course which next century is leading us to very, very dangerous climate change. So some people say, okay, let's not worry about mitigating, let's just adapt. Okay? If mitigating is too hard, we'll just have to adapt. Humans are clever. Think of what the world was like 100 years ago. The human world's been transformed in 100 years. We're extremely good at, we'll think of something. Technology will save us. This graph was, again, it was a CSIRO report looking at limits to adaptation. So each of these bars is a different sector or domain. There's water security, coastal communities, energy, infrastructure, health, tourism, agriculture, food security, natural ecosystems, kind of an overall indicator of sustainable development. And this is the 2 degree safety bar. The reason the 2 degrees wasn't pulled out of the hat. That was the result of a lot of analysis, and it suggested that if we could limit climate change to within 2 degrees, it was within easily within the adaptive capacity of societies, and we would only need to make minor adjustments, and they would not be too costly or difficult. If we go much over 2 degrees, we're into the yellow and red, and we're going to have to make major adjustments, and that starts to get very expensive. And if we go much further, we're beyond the adaptive capacity of our current systems, and we have to radically transform the kind of system we have. So to give an example, a minor adjustment in the agricultural sector might mean that we grow a new variety of wheat. A major adjustment might be we can't grow winter wheat in southern Australia, but there's another crop we can grow. A transformational change is there's no agriculture in southern Australia. So business as usual would seem to be pushing us into a zone later this century where we're up here everywhere. So what's the cause of this change? Well, it's burning fossil fuel. It's primarily burning fossil fuel for energy. It's the primary cause of human-forced climate change. So really reducing fossil fuel emissions is the only solution. Of all the human-caused greenhouse gases in the atmosphere, above and beyond what's natural, about 2/3 of them are from burning fossil fuel, and about 1/3 is from land use change, from depleting ecosystem stocks. But that proportion is changing because land use change is levelling off and our fossil fuel use is increasing, and we're not running out of fossil fuel. We might be running out of cheap oil, but we're not running out of coal and we're not running out of natural gas. And we're using this to generate electricity and for transportation. So if burning fossil fuel for energy is the primary cause, the question then becomes by how much, by how quickly, by when do we have to do this? So this graph is from, it just plots in time again from 1900 up to 2000, global CO2 emissions. One of the things I'll point out that sometimes this vertical axis is carbon and sometimes it's carbon dioxide. You've got to always look to see what the unit of measurement is here because they're related but different. Basically, to go from carbon to CO2, you multiply carbon by 3.67. So CO2 is always a larger number. Anyway, this tracks emissions over time up to about 2010, and we're nearly at 40 billion tonnes of carbon per year. So what do we have to do? How does that curve, and this, if you like, this is the emission curve, and it obviously has to decrease if we're to stabilise atmospheric concentrations of CO2 to keep global temperature below that 2 degree safety rail. So that decline in the emissions is called a contraction curve. It's basically got to do this. So that red curve is business as usual, right? And this is what global human greenhouse gas emissions have to do, roughly, in order to stabilise temperature at no more than 2 degrees. It basically has to get to zero between 2080 and 2100. It has to go from about 40 billion tonnes of CO2 a year to about zero, somewhere between 2080 and 2100. Now, to put a positive note on this, if you take the area under the curve, if any of you remember any of your high school calculus, right, you can calculate the area under the curve. Well, if you think about it, that's the total amount of fossil fuel emissions that humans have to emit over the next, say, 100 years or 90 years. Okay, that's the total. The area under the curve are the permissible emissions. They have to decrease each year to zero, but there's some there. So, that's a good question. What's the total area under the curve? What's the total amount of fossil fuel carbon that humanity can emit to limit climate change to 2 degrees? Well, it's about 1 trillion tonnes of carbon dioxide, or about 367 billion tonnes of carbon. And in 2009 we emitted 30.8, so it's about 44 years worth of the current annual emissions. That's what we've got to spend, right, over the next period of time. And I've got various sources because this has to be estimated, and it's not a straightforward thing to estimate, and there's a range of values, but that's a pretty, most people come to a number that's somewhere around there. So I call this the global carbon budget pie. Yeah, okay. That 1 trillion tonnes of carbon is what we have to consume one way or other. Now there are some kind of facts, scientific facts about the carbon budget, the global carbon budget pie. The pie can't be made any bigger. Nature made it. Okay, it's the pie that's been given to us. We can't make a second pie. Okay? There's not another planet where we can stick all these emissions. If we up all the pie now, this might sound an odd thing to say, but you cannot make another pie for 30 to 100,000 years. Why do I say that? Well, eventually, when you put carbon into the atmosphere, it dissolves into the ocean, and eventually it works its way to the bottom of the ocean and weathers rock and gets incorporated into the sediments at the bottom of the deep ocean. So eventually it works its way down to the deep ocean storage, currents at the bottom of the deep ocean, stops interacting with the atmosphere, and eventually it weathers rock and gets incorporated in the sediments. So eventually, if we wait long enough, wait 100,000 years, the whole system will kind of reach a new equilibrium again. But it takes a long time. So one way of thinking about it is, yes, the Earth will, Mother Nature will make us another pie, but it will take a long time. From a human point of view, we can't wait that long. So if you think about it, over the next 70 years, the global carbon budget pie has to be shared somehow between 7 billion people living in 193 sovereign states. So who's going to get the pie? Well, the UN Framework Convention on Climate Change is an international treaty that most of the world's nations have now signed, including Australia. And it was designed specifically, it's called the Framework Convention, because it was designed to provide a framework so that nations each year could meet and negotiate on how to fix the problem, how to solve the problem, as I've defined it, and also how to adjust or adapt to the unavoidable impacts of climate change that we're going to get. So every year, the nations of the world who have signed the convention, which is just about everyone now, except a couple of nations, I think, meet at what's called the Conference of the parties to the convention, Climate Change Convention, and they negotiate agreements, protocols and the like to try and solve the problem. It was an outcome from the Rare Earth Summit. Australia is a signatory, and we have effect, when you sign it, you effect give your consent to be bound by the decisions, would be the legal phrasing. And many nations such as Australia have enacted legislation to give effect to their treaty obligations. We have a Clean Energy Futures Act which does this. I've already said that. Now, cast your mind back a couple of years. There was one of these conferences of the parties at Copenhagen. Remember the Copenhagen Climate Change Conference? And there was a lot of publicity about it because the NGOs in particular said, we needed to get a legally binding mitigation agreement here that would prescribe national targets and timelines for the deep cuts in fossil fuel emissions to do what I've just described, to agree upon how much each country would reduce its emissions each year so that we follow that contraction curve to eliminate emissions by towards the end of this century and limit climate change to no more than 2 degrees. And we failed. The Copenhagen conference was declared a failure because we didn't get this agreement. We didn't get the real deal. Instead, we got something called the Copenhagen Agreement, which the US government, which led it, hailed as a great success, and which the Australian government said wasn't too bad. But the NGO critique was this was pretty poor. Why was the NGO critique poor? Well, it does not set time-bound targets for emission reductions from countries. It promotes a framework for kind of future agreements that's based entirely on voluntary pledges. Each government can just decide what it wants to do by when. It'll be a voluntary pledge about their own domestic targets. They'll tell the UN will add it up, and we'll get what people want to do independently, without negotiating. Independent voluntary pledges. And interestingly, for reasons I'll discuss shortly, the burden of emission reduction kind of effectively shifts to the developing world. And this has some implications I'll talk about in the future. Well, some people have said, yeah, that's true, but does it really matter? We're wasting time trying to negotiate, the real deal, because the world's actually taking action. I mean, let's not talk about what we should be doing. Let's deal with what the world community can do, what nations can do, what bilaterals can achieve, what the private sector can do, what civil society can do. Anyway, international law is not legally enforceable, so it's what people do, not what nations say they'll do that count. And finally, well, after a couple of years, mitigation action is actually happening under the Copenhagen Accord. So there. So if you look at what's going on, under the Copenhagen Accord, here's a list of all the emission reduction pledges by different countries. So countries representing about 83% of global emissions, have engaged with the Copenhagen Accord and submitted voluntary pledges. So the argument is that's a pretty good outcome. There's a map from a Climate Commission report. Under the Kyoto Protocol, which was for basically OECD countries, you had about 27% of countries responsible for about 27% of the emissions. Under the Cancun Agreement from the Copenhagen Accord, you've got countries that account for 83 emissions. Now, that's not saying that countries have pledged to reduce emissions by a total of 83%. It's just saying you've got the countries at least making voluntary pledges and they're taking some kind of action. So at least we've got something going on in the real world. But if you look at those commitments to date, they don't actually they won't deliver a 2-degree safety bar. This is one bit of modelling that's represented by a thermometer. Current pledges will stabilise by 2100 temperature at about plus 3.3 degrees. So that's kind of problematic, I guess. We do have pledges and they're voluntary, and even if you add them all together, going forward, you don't, you're quite a way above the 2-degree safety bar, and there are reasons for that I'll talk a bit about in the future. It's to do with where the emissions are coming from in the future. And also the commitments come with commissions, and this is a UN report, and I've just got some details here. So this is Australia's commitment, okay? Target of 5%, so a 5% reduction in emissions relative to year 2000, up to 15 or 25%. Now, the 15% is conditional on there being a global agreement and a functional carbon market, and the 25% target is actually that there's an ambitious global deal capable of stabilising at the 2-degree safety bar. So the Australian, any significant commitment from the Australian government is actually conditional on there being a binding global agreement. Like it's a little bit confusing, isn't it? They don't want a binding agreement, but their commitment to the deep cuts that are needed are actually dependent upon a much more ambitious global agreement than the one they're currently committed to. And all the countries are the same. Canada's one is interesting. It's 17% relative to 2000, as long as the USA puts in place legislation. So the Canadian one's dependent upon what another country does in terms of legislation. This is the EU one. It's 20% by 2020. It's 30%, again, is conditional on a global comprehensive agreement post-20, which involves everyone, developing and developing countries. Japan is 25% relative to 1990, conditional on a fair and effective international agreement, and so it goes on and on. Every country's commitment to making the deep cuts that are needed to prevent dangerous climate change is actually conditional on there being a comprehensive global agreement, and on it goes. So without a new global agreement, the Australian government will only commit to reducing emissions by 5%. Nations will not commit to mitigation targets and timetables that will stabilise atmospheric concentrations of CO2 at a level that prevents dangerous climate change, and therefore will end up in a temperature regime where the adaptive capacity of most, if not all, sectors will be exceeded, and we'll be having to think about transformed systems rather than just make minor or even major adjustments. There's a lot of major ethical issues I don't have time to go through, given I've only got 4 minutes left, but basically OECD countries got rich from causing climate change. The poor countries who are least responsible will be the most vulnerable to future climate change impacts. Developing countries and economies in transition, like China, need economic growth to elevate poverty. And these big countries in particular, the emissions are actually, their emissions are essentially part of the mitigation solution, so they're in a real bind. Currently economic growth requires burning fossil fuel, and they have a lot of legitimate development needs, particularly just to alleviate the severe poverty that's in their countries. Yet the growth in emissions in the next 50 years is going to come from big and other countries. So I think we do need at least a framework agreement that with national targets that explicitly are bound by or are a carve-up of the global carbon budget pie. I don't see how we can escape that. We have to deal with the total permissible global carbon budget and the entire emission contraction curve. So we have to have national targets that are related to the pie and a timeline for reducing it that will stabilise emissions so we avoid dangerous climate change. We have to deliver this in a way which gives us climate justice but without vengeance. Okay? Like, what do I mean by that? We know that the developing world has been, the developed world has been responsible for the emissions to date. So the issue is not to punish them for doing that, but to work out how we can give justice to developing countries going forward, given that we've got a finite pie. So we need to deal with issues of equity. And I don't have time to talk about one model. There's a model called contraction and convergence, which is a way of doing that. So to conclude, I think that the UN Framework Convention on Climate Change is the only game in town. Without it, there is no universal climate change regulatory framework. So I think it's a UN negotiated agreement versus anarchy, voluntarism, bilaterals between rich and poor countries, the fortuitous aggregate impact of random acts, or charity. There is going to be, what does charity mean? Well, we are now locked into the unavoidable impacts of climate change, and the wealthy countries who have got rich from causing the climate change, have a moral responsibility, and I would argue even a legal responsibility, to help resource and fund developing countries to adapt to those changes. And this should not be taken from a position of charity. It should be taken from a position of distributed justice. It's an issue of justice. It shouldn't be an act of charity. And I think, and I'm happy to hear Andrew's, view on this, but I think international law does work, or kind of works. Nations have a habit of being law-abiding, because there are benefits. There's certainly reciprocity, tit for tat. The UK government threatened the country that's giving our compatriot refuge in London, Ecuador. They threatened to burst down the gates of Ecuador's embassy, and they reminded UK they signed an international treaty not to do that. There are supporting mechanisms. There are international courts of appeals. There are precedents in the UN for putting economic sanctions on countries for behaving poorly. We have given our assent to be legally bound, sense of lawfulness, and nations do implement national implementation. So international agreements, they may not be legally enforceable in a simple way, but there are processes and mechanisms that put pressure on. So finally, I've said the pie cannot be made larger, nor can a second pie be cooked. Therefore, the challenge is, sure, there's a real politic of political negotiations must now come to grips with the reality of what I call the real scientific of what the Earth system can absorb, and that's the challenge before us. Can we have international negotiations that are prepared to operate within not without what the Earth system can deal with. Thank you.